Okay, hi guys. We know the universe is expanding because we can observe the effects of its expansion in the spectra of galaxies. As the galaxies recede, the wavelengths of light coming from them are lengthened by the expansion of space itself. This stretching of wavelengths is called redshift. Redshift. It can be demonstrated with this balloon right here. Okay, and so what I'm going to do is I'm going to blow up this balloon about halfway. Okay, that's good right there. And then what I'm going to do is I'm going to draw a grid on it. Okay, so bear with me. It's not going to look real scientific, but good enough. Okay, and this is just a grid I'm drawing. I'm going to put a wave on it here in a second. So there's our grid. And then I'm going to draw a wave that represents like a wavelength. Okay, so there's our wave. I'll come out the end a little bit there. Okay, good. There's our wave. And if I were to measure it, in fact, I think I'm going to measure a couple things. I'm going to measure the grid and the wavelength. Okay, so the grid, let's go centimeters. The grid is about, 6 centimeters, roughly. 6 by, let's say 4. And these are centimeters. And then the wavelength, the wavelength is going to be the same as the length of it. I just want to double check that. So the wavelength is going to be about 6 centimeters, just the same as the length of the grid. Now I'm going to blow it up further. That's about as far as we can go without popping the thing. And so now the length of the grid is about 11 by 7. And the wavelength is now going to be about 11. So it almost doubled. Almost doubled. Okay, so what did this tell us? So as the balloon expanded, so did the size of the grid and the length of the wave drawn on it. This relationship between the wave and the grid doesn't change. The two are linked together. As one grows, as the grid grows, so does the wavelength. Now, let's tie that to the simulation, to the visible spectrum, what you can see as far as scientists can see as far as wavelengths. Blue wavelengths of light are short. Red light has the longest visible wavelength. That's why it's called redshift. Shorter wavelengths of light are stretched to longer wavelengths as the fabric of space expands. So this balloon simulates the universe. And as the universe grows, the grid and the wavelength grow as well. Now, if this wavelength is light, the light goes from short wavelength to longer wavelength. Longer wavelengths are red. Okay, so when a scientist looks through a telescope, or they look at the sky, and they see things that are red, they know that those are longer, further away objects because they're showing red compared to blue, which is a shorter wavelength. Hope that makes sense. Please watch the videos to try and tie this demonstration into what we're talking about. Thanks, guys.